So in this question, you're given that A1 is the area of the circle and A2 is the area of the inscribed pentagon in that circle. You're asked to find A1 is to A2. So you have a circle of radius is equal to R and you have an inscribed pentagon inside this circle. So you're asked to find the ratio of the area of the circle to the area of the pentagon. So let us say that the radius of the circle be equal to R. So obviously A1, which is the area of the circle, is nothing but pi R square. Now, can I write the area of the pentagon in terms of R? So let us say that A is the side of this pentagon. Now, what is the area of the pentagon? Area of the pentagon is nothing but 5 times area of triangle OAB. So if you take any one side and join the side endpoints of the side with the center, you get a triangle and you get 5 similar triangles, 5 equal triangles for correspond to each side of the pentagon. So area of the pentagon is 5 times the area of this triangle. So what is the area of this triangle? Area of this triangle is half times product of two adjacent sides, half R square, sine of the angle between these two sides. So what is the angle between these two sides? The total angle is 2 pi. So this angle will be 2 pi by 5. Total 2 pi angle is being divided among the 5 sides. So 2 pi by 5. So A1 is pi R square, A2 is this. So you're asked to find A1 by A2. So R square and R square gets cancelled. This 2 goes up. So A1 by A2 is equal to 2 by 5 times sine 2 pi by 5. So this will be the corresponding ratio which is required. Thank you.